if you're watching this, then you've already gotten done with the assessment, you've gotten done with the assessment review, and now we're learning something a little bit more fun. I think it's a little bit more fun, but there is a bit of a twist to it. So the idea is called a one-step transformation mapping practice, where what we have to do is we're starting with an original triangle, we're seeing what the final triangle is, and we're trying to figure out what the transformation is that occurred. On the assessment, they have these, and they're pretty straightforward, and part of the reason that they're straightforward is because they have pictures. And so for these, so I've got these 3 problems here, and we're going to go through the first 3 problems, or we're going to go through these 3 problems, and just kind of review what to look out for and what to see. So we've got triangle. So for the first one, I'm just going to set up a, I've got 6 points, so I'm going to put this here. So the original triangle is at 1, 2, 1, 2, 3. That's at A. Triangle point B is at 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then C is at 6, 2. 1, 2, 3, 4, 5, 6. 1, 2. All right. That's C. And when you're asked to do this on the assessment, it is going to be a lot easier because they're going to give you 2 pictures. This one I'm just kind of trying to get the same question in, but with fewer resources. So the final triangle is at negative 1, 2, 1, 2, 3. That's point A. A prime. B prime is negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then C prime is at, all right, I can already see what's going on. 1, 2, 3, 4, 5, 6, and then 1, 2. So basically, based on the shapes, what can we say was the transformation that happened? Well, having the pictures makes this so much easier. And with the next worksheet, it'll make it just stupid easy. But what I can tell here is that I've got, if I were to guess, hypothetically, that this was a reflection along the y-axis, what evidence do I have that would back that up? First of all, the A's are right next to each other. If the A's are right next to each other, then that usually means that there is a reflection. It's not a rotation. It's also not, it's usually a reflection, not a rotation. We also see that if we take a look at the triangles and their relative positions, we know it's not a translation, because if it was a translation, point A on the bottom left would also be point A prime on the bottom left. So even accounting for bad drawing hat practices, it looks like it's just going to be a reflection about the y-axis. Which it absolutely is, because A prime is 2 spaces away, A is 2 spaces away from the line of reflection, B is 1, 2, 3, 4 spaces away, B prime is 1, 2, 3, 4 spaces away. So yeah, so this is a reflection about, this would be a reflection about y-axis. Okay, so there's that first one. It's like I said, what makes these challenging is just looking at the numbers. So if you have graph paper, or you will have something, or you'll have something different, then it'll make all of these a lot easier, and you will have those resources. Let's see, I'm drawing on a different part of the graph paper, so just bear with me for a moment. 1, 2, 3, 1, 2, 3, 1, 2. Nope. 1, 2. There we go. That's the one. That's the direction. And then 1, negative 2, 1, 2, and then negative 1, 2, 3, and then up 2. All right. And I'm just labeling all the points down here. So I've got P, Q, R, and S. Now I'm going to do the final rectangle. Actually, I'll just do it. Yeah, I'll do it this way so you can actually see what I'm may not be able to see what I'm reading, but you can at least see what I'm drawing here. So final rectangle is 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. That's P prime. Q is 1, 2, and then 1, 2, 3, 4. I can already tell you what it is. R is 2, 4, so 1, 2, 1, 2, 3, 4. And then S prime is 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4. Yeah. I kind of guessed what was going on pretty, yeah. Yeah, you can. This one's actually, if you do the drawing, it's pretty clear. This is a dilation. This is very obviously a dilation because the points are in the same relative positions, but they're just farther away from each other. But I would also suggest that it's easy to tell here too, because if you just do a quick look, a quick assessment, you have -3, -6, so that increased, so that doubled. -2, -4, that doubled. 1, 2, that doubled. 2, 4, that doubled. So what you have is a dilation where k equals 2. So there we go. Next we've got problem 3, and I'm going to do this triangle here on, yeah, I just need this much space. So -2, 5, 1, 2, 1, 2, 3, 4, 5. And then 1, 5, 1, 1, 2, 3, 4, 5. Then 1, 2. So there we go. This is our third triangle and our final one. So we've got, oops. So this is X and Y, Z. And if you're doing stuff like this, it's important to keep the points labeled because, like I said, it'll give you some clues based on what the final transformation is. So the final triangle is -5, -2, so 1, 2, 3, 4, 5, 1, 2. Y prime is -5, 1, 1, 2, 3, 4, 5, 1. The Z prime is -2, 1, 2, -1. Well, I guess I'm just not that good of an artist, I suppose. -5, -5, -2. That's why. Alright. No, that's... Anyway. So what transformation occurred here? Well, this one's actually, I'm actually kind of impressed with this one. So what I see here, so let me tell you what I see here. I see, well, first I got to verify that I've got the right points in the right location. So 1, 2, 3, 4, 5, 1, 2. Okay, so that is X. Y is 1, 2, 3, 4, 5, and then 1, okay? And this one is -2. There it is. -2, 1. There we are. It's not -1, it's -2, 1. All right. So this is Z prime. There we go. Okay, this makes a lot more sense now. Makes a lot more sense. If you remember, XYZ is, if you take a look at the original one, XYZ is basically traveling along the path of the right angle. And so this would be our 90-degree right angle here. And if you follow X to Y to Z, we're getting on that right angle. The right angle is here also, X to Y to Z. But now X is down and it's going up. So what I think happened is we've got a 90-degree counterclockwise rotation here. Because if you take a look, because putting it in relative terms. So if you think about where's the right angle going? If you start with, if we just have a square here, the right angle is originally here. But after a rotation, now the right angle is here, relatively speaking. And so if we did another 90-degree rotation, I don't know where exactly it would be, but the 90-degree would be here, bottom left, and then one more, wherever that one would show up, and it would be here on the bottom right. And so because the right angle is rotating like this, I know that it's a counterclockwise rotation. And because it just moved, and because it just basically moved one quadrant over, I know that it just moved one area. So, I mean, a lot of this requires some observation skills, requires a little bit of visualization, but it also requires a little bit of abstract and creative thinking too. But again, once you have the drawings in front of you, most folks can probably figure this out. So 90-degree counterclockwise rotation. So yeah, that's just one-step mapping, one-step mapping practice. So that is when you see when you see an image and a pre-image, and then you got to pick out one transformation that makes it into what it is. Hopefully things don't get any more complicated than that, right? I can't imagine that they would, but I don't know. Let me go check the assessment, see what I can do.